Welcome to Application Programming in Python. This is a short presentation performed by Adam Hughes and Rob Coyne for the George Washington University Physics Department. It is about application programming in Python, exactly what the title says, or how you can build your own Python applications using the Enthought tools suite. Quick disclaimer, neither of us are trained computer scientists, and this presentation was made for non-computer scientists as well as amateurs. So we will sometimes get crossed up on a bit of the technical jargon, but we'll try to keep things clear for the sake of the presentation.
And we're not employees of Enthought or affiliated with the company in any way. Alright. So first we're going to introduce some motivation for applications and why you would want to use applications. If you don't need this motivation, you can skip ahead about 10 minutes. We're going to give some application examples and why it's difficult to build them given the standard library in Python. Then we're going to introduce Enthought traits and traitsui as some basic tools for application development, and after that we're going to show some advanced application tools for plotting and other features. Before I start, we should mention what we mean by application programming. Application programming is generally used in contrast to procedural or imperative programming. This is the type of programming that most people are familiar with, wherein imperative programming is really defined by linear flow. There's a non-interactive or limited user interface, and generally the input is entered into the program, it's manipulated, and then output is generated. The workflow is completely linear. In contrast, applications feature a graphical user interface. They have to be interactive, and usually they have to be more robust to protect from user error or other problems. And this adds a great deal of complexity to the program, which I'll show you a more specific example why this is the case. So first off, why would non-computer scientists want to bother with this? Well, first, many users these days aren't going to use your programs if there's a non-user interface. Most programs that we're familiar with always have a graphical user interface. So if you ever want to distribute your software, it has to have a nice interface. But even if you're not going to be distributing the software, even for your own research, it's important to be able to use applications. First, because visually driven programming leads to easier error spotting. It's important to have transparency between your parameters and your results, because this gives high throughput. You get a better understanding of the internal relationships that aren't always apparent through the mathematics, and you can troubleshoot a lot easier. And I'm not here to motivate you to do this. I think if you're here, you're probably somewhat motivated yourself. So let's get right into it. Now, first off, why is this in Python? Well, I can't speak again for Enthought, but Python is a highly supported language in community. It has optimal syntax for easy scripting. Python can be object-oriented or procedural, meaning for basic programs you can really write them quickly, but for sophisticated programs you get all the power of object-oriented programming. There are significant scientific and numerical packages for Python which mimic functionality of MATLAB and other softwares. Python has a lot of good tools for 2D and 3D visualization, which I'm going to show you later. Python can be integrated into other programming languages such as C, Fortran, C++, SQL, and others. There's a lot of GUI support for Python, and there's a lot of other interesting packages such as PyAudio, Django for web framework development, and other reasons. The problem with building applications is that even though the tools are available in Python, like I just mentioned, an application is generally more than the sum of its parts. Even though all the tools and pieces exist, making them work together is effectively difficult. And here's why. You can see in the left network diagram I've put an imperative program with a linear workflow. And even if you have complicated numerics and scripting, the programming environment that you generate is generally linear, and generally it's easy. However, when you make a user interface, there has to be feedback between most areas of the program and the interface. Now, I've indicated the feedback loops with a red arrow, and you can see that the complexity of the program is highly magnified by adding this small interface component. I've also shown a green node to indicate that even though you have a variable internally represented in your program, having that variable mapped to the GUI representation is not always straightforward. So in general, applications are difficult to build because there's extra feedback for events that is needed, and there needs to be a mapping between variables from the GUI to the internals of the code. Let me show you a concrete example for you. Alright, so here is an example, a concrete example of building an application. You can skip ahead if you need to, if you're not interested in this basic Python. So this is a program where we would simply take two integers from a user would input two integers and the program would see if they sum to 42. So this is a very basic program, and you can see when Rob enters 40 and 2, the program says yes, they sum to 42, and when Rob enters 30 and 5, it says no, you're dumb. And this is a very easy program to write, so if we look at the source, it's only going to be 11 lines. Basically, the user enters raw inputs, the program adds them and decides if they're equal to 42. And as it stands, this is only an 11-line code. But it's not an application because, one, it does not stay open. Rob has to execute it over and over again. It also crashes with bad input, which we're going to show you. So if Rob runs this program one more time, and he enters a string for A, then the program's going to crash. So just to remedy these two issues, one, that it has to stay open and prompt Rob to exit, and two, that it can handle bad input, let's see what we have to do. So let's show the source to the modified version. Now, I'm not the best programmer out there, but I can figure this out, and you see what I had to do is I had to extend the program to triple in length, so now it's 35 lines rather than 11. I've also had to add these two functions, which really do nothing but track things and make sure that the user doesn't mess up. So I had to triple my code, I had to add temp variables, I had to add unnecessary functions, and I had to do all this just to get the computer to have these basic features of applications. Now if we run it, you'll see that it does work. Okay, so right now I've corrected for these issues, and you see that now Rob, the program has the same functionality, but it stays open and it prompts Rob if he would like to try again. Obviously it's not much of an application. It also can take string inputs, so if Rob enters a string, 1 second. Yeah. So you see it still has the same functionality, and it does not crash when Rob enters a string. So all we fixed was that the program will stay open unless prompted to close, and that it could take in some sort of bad input. These are very small fixes, and this isn't even a graphical user interface. But if you look at the source, to do these fixes, I had to increase the source. I had to triple the amount of codes in the source. I had to add two functions, check A, B, and try again, which do nothing but handle these events. And I also had to include a lot of temporary variables. And I'm not the greatest programmer, but I'm good enough. And I think the fact that I had to triple the program just to get this basic application input is hinting at the idea that we need some extra tools for building applications. Now, if you spend your time trying to build these applications from scratch, you're going to spend 90% of the code on these handlers, and you're not really going to get much for your money. Enthought is a company that develops application tools, and at the core of their application tools are these so-called traits and trait UI objects. Instead of defining my variables internally as standard Python variables, what I can do is I can define them as traits variables. And the key thing about traits variables is these GUI mappings and these feedback loops, which I showed were the things that make applications difficult to develop. These are built into the trait objects themselves. Essentially, you're not going to have to worry too much about the visual mapping or the feedback loops when you define traits, because traits have these functions built into them. I think this diagram here demonstrates what I'm talking about. Now, for simple programs, this means that you're going to get notifiers and GUIs more or less for free. And then when you build more complicated programs, you're going to be able to have less syntax. You're going to have a lot more tools to work with, and it's a really nice feature. So let me show a couple examples of this. Okay, so I'm showing the source for an example, and this is a very simple object. You can see on the top I have the standard Python definition for this object called foo. This object has a string and an int variable, foo and bar respectively, and they're initialized at the definition. Now on the bottom I have the traits object, and you can see it's the same length. The only difference is now it's not a standard object, but it's inheriting from this has traits package from Enthought. You also see that the variables aren't standard variables because they're not lowercase strings and ints, but capital strings and int declarations. These are indicating that these are trait variables, a trait string and a trait integer. But at the surface, there's really not much difference. But let's look at how defining my variables and traits could handle my sum to 42 application. Now, again, if you look at this, now my program is 11 lines again, meaning it's just as simple as I originally had it when it was a non-application. But you see some special syntax in here, so what I have is some event listeners. I'm using these so-called properties, and this is a has traits object. So let's go ahead and run this, and I'll show you in 11 lines what you get with it. Now, the first thing you're probably going to notice is that you get a graphical user interface. Like I said, the graphical user interface is just part of the trait objects themselves. Now, when Rob enters some variables, you see that the functionality that we want is achieved. Not only is the status recognizing that it's equal or not equal to 42, but the sum is also being projected as a variable. You also see that when Rob enters poor input, there is a red backlight in the entry box indicating that the input is wrong, but there is no crashing. So we get all the functionality that we wanted. We chopped our code back down to 11 lines, and we get a graphical user interface. We also get some buttons, and none of this was really defined by us. So this is how using traits can really extend the applications that you build. Continuing with that, we can look at traits a little closely, and the nice thing about traits is they really develop a good framework for users to separate their model or their underlying data from the view that they want to present. Therefore, I'm going to show you a couple advanced view elements or view concepts, and then I'm going to show you how some advanced trait listeners could really provide some good tools for monitoring and controlling feedback in your program. So let's run example 3. Okay, so on the right screen, in the right panel, you're going to see the example I just showed you. Now, on the left panel, I've taken the same exact object, so you can see that the object, the definitions and the traits are exactly the same, but I've defined these variables view1 and view2, which are going to let me change how the object is presented to the user, but you'll see that I do not change the underlying object itself. So this is an example of how I can use the view object and traits to customize what I want. So let's run what's on the left panel. And you see, using the view 1, I've changed the way it's presented to the user, but the code still works in the same way. I took out the buttons. I've used some horizontal groupings. I've also made the window resizable so Rob can drag it. I've also defined another variable, view2, which we can switch. So if we look at this other view, let me just let Rob comment out the call of the first view. Yeah, so if you just comment out, if you just change this here.
This one?
Yeah, to view2. So all I'm going to do is call the second view, and you'll see that the program looks even more different. So what I did in the second view was I added a title. I added some undo and redo buttons, and these are some nice features because you don't have to program these yourself, but they work with any program. So